Welcome to the Bourns Transient Current Suppressor training module. The objective of this presentation is to provide an introduction to transient current suppressor, or TCS, products, gain an understanding of product characteristics, and discuss product applications. After a brief description, we will look at the TCS device's ability to limit current along with its other characteristics. We will look at TCS packaging and discuss data from various testing. Finally, we will cover a Gigabit Ethernet application. A family of dual-channel devices was designed to provide a current-limiting function as well as voltage isolation between a voltage-limiting device, such as a TVS diode, and the circuit being protected. There are 3 current-limiting levels available, and they are packaged in dual-channel configurations. A TCS device exhibits a behavior with current that is analogous to the behavior of a TVS diode with voltage. A TCS device holds current relatively constant as voltage increases, whereas a TVS diode holds voltage relatively constant as current increases. In a similar manner, a TCS device has a maximum voltage capability rating, while a TVS diode would have a maximum current capability rating. This curve was generated using a 1 volt per microsecond slew rate ramp. This provides a good description of how the device will behave under transient conditions. Note that as the voltage across the device is increased beyond the current trigger threshold, the current through the device will slowly increase. This is analogous to the voltage across a TVS diode increasing as the current through it increases. All the TCS devices are packaged in a DFN package with the length of the device, B dimension, directly related to its trigger current rating. Bourns TCS devices behave like a high-quality resistor. The 3 different current limit rated devices all show a low insertion loss to 6 GHz. The surge duration capability of the TCS family of devices is well beyond the waveform durations of all of the transient surge standards. For the TCS-DL004-250-WH, the maximum duration at 25 degrees Celsius with 20 volts across the device is just over 100 milliseconds. The maximum duration at 85 degrees Celsius with 40 volts max rated voltage across the device is approximately 7 milliseconds. A 10 by 1000 millisecond surge will not present a problem within rated limits. Surge current duration graphs are provided for all of the devices in the TCS product datasheet. The voltage limiting device can be a TVS diode, a thyristor, or clamp diodes to a supply rail or ground. The TCS device will limit the current into the protected device during a surge event as well as provide voltage isolation between the voltage limiting device and the protected device. A test circuit was put together to evaluate and demonstrate the response of the TCS family of devices. The graph shows the response of the TCS-DL004-250-WH device to a 1 volt per microsecond slew rate impulse voltage ramp. Note that once the trigger current level is reached, there is some foldback in the current limit level. The current will then rise in a controlled manner as the voltage across the device increases. Under these test conditions, the trip current is approximately 480 milliamps, folding back to approximately 250 milliamps and then rising back up to about 480 milliamps as the voltage across the device is increased to the maximum rating of 40 volts. The TCS-DL004-500-WH and TCS-DL004-750-WH devices exhibit a similar response, only with higher current limit levels. The diagram shows a generic circuit topology using a TVS diode for overvoltage protection. Let's evaluate this circuit using 1/2 of a TCS-DL004-250-WH TCS device, a CD-SOD323-T05C TVS diode, and a 3.9 volt Zener diode to represent the ESD clamping function of the device under test. In order to demonstrate the operation of the device in an application, the TCS-DL004-250-WH was evaluated under surge conditions in a test circuit using a 5 volt TVS diode for overvoltage protection. A 3.9 volt Zener diode was used to represent the ESD structure of a device to be protected by our circuit. The graphs show the response of the TCS device to a 1.2 by 50 microsecond voltage and 8 by 20 microsecond current combination wave. Note that the peak current is slightly higher than the test on an earlier slide, 550 milliamps versus 480 milliamps. This is because the slew rate of this surge waveform is significantly faster than our previous test waveform's 1 volt per millisecond. The current folds back to less than 300 milliamps. The TCS-DL004-500-WH and TCS-DL004-750-WH devices exhibit a similar response, only with higher current limit levels. Summarizing the results of our test, we see that the voltage across the protected device is approximately 7 volts, which is 9 volts lower than the voltage across the TVS diode. We also see that the current into the protected device is quickly reduced to about 300 milliamps after the initial peak of 550 milliamps. This schematic shows a surge protection design for a Gigabit Ethernet application. A TVS diode is used as the voltage limiting device. This solution provides enhanced protection compared to a design that uses only a TVS diode. On the next slide, we will demonstrate the difference in the level of protection. These two photographs clearly demonstrate the dramatic reduction in the stress level that the physical layer device, or PHY, would be subjected to when the TCS-DL004-250-WH is used. In the left-hand photo, only a 5-volt TVS diode is used to protect the PHY. We can see that the peak voltage across the differential signal input to the PHY is just over 12 volts, while the peak current into the PHY is approximately 4 amps. When the TCS-DL004-250-WH is added to the circuit, we first notice the dramatic reduction in the PHY input current. After the initial peak of 0.5 amps, it quickly folds back to approximately 250 milliamps. The TCS device also provides voltage isolation between the TVS diode and the PHY under protection. The voltage across the differential input to the PHY is determined by the ESD protection circuit's response to the significantly reduced input current. Note that compared to the TVS diode-only design, the PHY differential input voltage is reduced by approximately 50%. The final conclusion is that the power and energy that the PHY is subjected to under this differential surge condition have been dramatically reduced when a TCS device is used in conjunction with a TVS diode. We can see that the energy absorbed by the PHY is reduced from approximately 50 microjoules to about 3 microjoules when the TCS device is added to the circuit. The addition of the model TCS-DL004-250-WH reduces the current seen by the PHY by approximately 90%. The voltage isolation provided by the TCS device reduces the voltage level seen by the PHY by over 50%. Combining these two effects, we see a reduction in the energy that the PHY must absorb of over 90%. The table above can be used to help determine whether a TCS device or a TBU device is appropriate for your circuit protection design requirements. The letter N in the device column designates that the device type is not appropriate for the listed condition, while the letter Y designates that it is. Continuous product development enables Bourns to provide circuit protection solutions for changing market requirements. Bourns Circuit Protection TCS Transient Current Suppressor products will bring significant benefits and enhanced performance to your application. Bourns offers a wide variety of sales and support tools. Bourns field application engineers capable of supporting your protection interface design needs are also available. Please contact Bourns at techweb@bourns.com for questions concerning TCS Transient Current Suppressor products. Visit www.bourns.com for more details.